Picture this. It is 1971 at Atlanta Dragway, and a quiet Georgia farmer rolls toward the starting line in what looks like a normal Pontiac GTO. The paint is clean, the stance looks familiar. Nothing about the car suggests danger. Then the hood comes off. Conversations stop. Helmets turn. Sitting on top of the massive 455 cubic inch Pontiac engine is something the factory never built and never approved. A towering aluminum tunnel ram, crowned with twin Holley carburetors, reaching skyward like a challenge. Pontiac said this engine did not need it. Arnie Beswick is about to prove them wrong. This is the story of how one independent racer outthought an entire engineering department and unlocked power Pontiac never intended anyone to find. Not with corporate budgets or factory dynos, but with instinct, patience, and a refusal to accept limitations. Pontiac's 455 was the largest displacement engine the company ever produced. With a 4.15-inch bore and a 4.21-inch stroke, it was designed to deliver effortless torque. Pontiac engineers believed in strong, low-end power, smooth drivability, and reliability. Their philosophy was simple. Big engines did not need high RPM tricks. The factory 455 relied on a single 4-barrel carburetor and a cast-iron intake. In stock form, it produced 335 horsepower and massive torque at low engine speeds. For the street, it was perfect. But racing is not about comfort. It is about exploiting every advantage the rules allow. By the early 70s, Chevrolet and Chrysler had already embraced tunnel ram induction. Long intake runners and dual carburetors were proving deadly in superstock competition. These systems used resonance tuning, where pressure waves inside the intake runners helped force additional air into the cylinders at high RPM. It was natural supercharging, with no belts, no blowers, and no mercy. Pontiac dismissed it. Their engineers argued the 455's port design and combustion chambers were not suited for tunnel ram use. They believed the engine's strength was torque, not airflow at high RPM. Officially, Pontiac said tunnel rams were unnecessary. Arnie Beswick did not agree. Beswick was not new to racing. He had been competing since the 1950s and running a successful speed shop in Georgia. He understood that factory recommendations were compromises, not limits. Super stock rules allowed aftermarket intake manifolds, and Beswick saw an opportunity no one else was willing to take. In his workshop, away from attention, he began experimenting with a massive tunnel ram intake. The runners stretched nearly 14 inches from the carburetors to the cylinder heads. Runner length, diameter, and taper were critical. Too short and the engine would lose torque. Too long and it would fall flat. Everything had to work together. On top, Beswick mounted two Holley 750 carburetors, 1,500 cubic feet per minute of airflow, far more than Pontiac ever intended. Synchronization was everything. Both carburetors had to open together, transition together, and feed evenly. Jetting became an obsession. The front carburetor required different tuning than the rear. Airflow dynamics changed everything. Weeks turned into months of testing. Spark plugs were read after every run. Exhaust temperatures were monitored constantly. Tiny changes produced massive results. But the tunnel ram alone was not the secret. The camshaft was where Beswick truly broke from factory thinking. Pontiac cams were designed for smooth operation and early torque. Beswick needed RPM. He commissioned a radical solid lifter cam with extreme duration and tight lobe separation. Idle quality vanished. Vacuum disappeared. Below 3,000 RPM, the engine felt lifeless. Then came the transformation. At 4,500 RPM, the intake runners began to resonate. Pressure waves reflected off the carburetors and returned to the intake valves at exactly the right moment. As the valves closed, those waves forced extra air into the cylinders, the effect intensified with speed. At 6,800 RPM, the engine came alive. Dyno testing revealed the impossible: 650 horsepower from a naturally aspirated Pontiac. 455. That was 1.43 horsepower per cubic inch, a number that rivaled professional racing engines of the era. Pontiac's factory 455 barely reached half that output. Torque followed the same pattern. While low-end grunt was sacrificed, the engine held over 500 pound-feet across a wide RPM range. On the track, that meant relentless acceleration from launch to finish. In superstock trim, Beswick's GTO ran 10-second passes at 134 miles per hour. Factory-equipped cars were a full second slower. In drag racing, a second is an eternity. Beswick did not advertise his advantage. During warm-ups, the tunnel ram remained hidden beneath a conventional scoop. Only during eliminations did he reveal it, when competitors could no longer adapt. The psychological damage was immediate. Drivers knew they were beaten before the lights dropped. Others tried to copy the setup. Most failed. They bolted on tunnel rams without understanding the system behind them. Without the camshaft, compression, headwork, and precise tuning, the intake alone did nothing. Beswick's success was not about parts. It was about balance. Pontiac noticed. Internally, engineers studied the results. Some pushed for factory development. Management refused. Tunnel rams had no street value, no warranty safety, and no place in Pontiac's evolving image. The idea died in conference rooms, but the proof was already written in elapsed times. The engine required constant maintenance. Compression was pushed to 12.5 to 1, demanding high-octane race fuel. Valve springs fatigued quickly and were replaced often. Carburetors needed constant adjustment for weather changes. Every run required inspection. Racing at this level was work. Driving the car was an experience few could handle. Starting it demanded patience. Idle was rough and unforgiving. Launching required precision. Too low and it bogged. Too high and traction vanished. The sweet spot was narrow and violent. When it hooked, the car surged forward with brutal force. First gear disappeared instantly. Second followed just as fast. The sound was unmistakable. Twin carburetors howled as they opened together, a sharp mechanical scream that echoed across the track. Racers said they could hear Beswick's car from the pits without seeing it. The tunnel ram also exposed weaknesses elsewhere. Transmissions failed, rear axles twisted. Safety equipment had to be upgraded as speeds climbed. Every improvement revealed another limitation to overcome, yet the success paid off. Prize money grew. Sponsorships followed. Beswick's speed shop business exploded. Racers traveled across the region to learn from the man who embarrassed a factory. The broader impact reached beyond Pontiac. Builders began questioning assumptions. If a tunnel ram worked on a 455, what else was possible? Big block Fords, Buicks, and Oldsmobiles soon followed. The idea spread that displacement alone was not the answer. Airflow mattered. By 1973, the era faded. Emissions rules tightened. Insurance costs soared. Factory performance collapsed. But the legacy remained. Arnie Beswick's tunnel ram 455 stands as proof that innovation often comes from outside corporate walls. It reminds us that engineering progress is driven by curiosity, not permission. Pontiac built the engine. Beswick revealed its true potential. Sometimes the most important breakthroughs do not come from factories. They come from individuals willing to challenge accepted limits and chase answers 1/4 mile at a time.